In the previous part, we delineated the watershed and created HRUs. In this part, we're going to continue with editing inputs and running SWAT. To do this, of course, you will need to have SWAT Editor installed on your computer. So, to proceed, click on Edit Inputs and run SWAT. We have also a database in the reference database that is found in the project file, but this one is referring to the default database if you see in this box here. So I'm just going to copy this path, copy using Ctrl+C, and then I'm going to replace this, paste. All right, so connect to databases. It says database connection successful, so I'll click OK. And now after doing that, I can start writing input tables. The first thing will be to apply weather data to the model. So I click on Write Input Tables, Weather Stations. So here, remember, we have a weather generator that will help us simulate weather variables if they are missing. So I will select it, click WGEN Robert. Remember, it has one record, that's why we have station count 1. Next we go to rainfall data. So we are not going to simulate rainfall. These are some of the most important inputs to our data: rainfall data and temperature data. Make sure that you have at least that data. The rest you can simulate, although it is really recommended to have all those data also available. All that. Alright, so we click on rain gauges and browse to find the locations table. So in our case, we have the dataset in climate robit. For precipitation, it's going to be pcp.rob_station.txt. Click on open, okay, and then we go to another tab, temperature data, climate stations. Do the same thing. This time we select on TMP and then click OK. Next, move to wind speed and select wind and solar radiation. We also have solar radiation, but as I said, if you have some missing data, you can simulate it. For instance, you could choose to simulate radiation data, assuming you didn't have it. So we're going to simulate this. Relative humidity, we have the data available, so we're going to select it and say open. Make sure you do not select the time series. Select the files that link the time series files. Okay, click on open and then okay. Once you do this, it's going to import that weather data into the database, and it says processing complete. Okay, now close by using this button. You could also click on cancel. If you click on OK, it will not close the dialog box, it will just repeat what happened. So this is the way to close it. Next, we write the SWAT input tables, and to do that we click here, and to select all of these, you cannot manually select them. So to select them, you select using this button that says select all, and then they're going to be selected. Then click create tables. So it's going to ask you if you want to use heat units to calculate the time to maturity, but this applies to the US. We're going to say no in this case. Do you want to rewrite existing data? Just click on yes and yes and yes. So it's going to write the files into the text in out folder. This is where all the ASCII files or tables are written when they are extracted from the project database. And when you run the model, it actually reads from these tables, from these files, and uses that information to execute the model. Now it says done building the selected tables. Click on OK, and then close the same way we close the other dialog box. Close. If you want to change some options like the method of calculating evapotranspiration or other parameters, or if you are doing manual calibration, actually you can do that by clicking on edit SWAT input, and then you can select what you want to change, which kind. So you have weather, and you have soils, HIUs, routing, groundwater. If you want to change management, and then you select subbasin, and so on and so forth. In this case, we're just going to focus on running our model. We're going to come back to manual calibration and automatic calibration in another part. So to run the model, you proceed to SWAT simulation and then click on run SWAT. So here you set the options like the duration of the time that you want to run your model, and at what time step you want to run it. And here you can select the beginning date. Click like that, and you could also, I'm just going to leave it like this. It tells you that you cannot simulate past this date. So are you going to print out your data or your output, your results in daily time step, monthly time step, or yearly time step? You can choose that here in print out settings. So I want to have my results in monthly time step. And also you should know that at the beginning of the model you're going to have 0 flows because there was no water in the catchment, and to let some storage of water and to let the model normalize, we run it for some time before starting to print our results. This is called the warm-up period, and you specify that by specifying the number of years that you want to skip before printing the results, and I recommend a minimum of 2 years. So we have 2 there, and you could also select other results that you would be interested in. You can also select the SWAT executable version. You have 32-bit and 64-bit versions. I'm going to select 64-bit release. Release is faster than debug, but the downside is that it will not give you enough information. It will not give you a lot of information when an error occurs. So if you have errors during the simulations, repeat the simulation using the 64-bit debug to get more insight as to what is wrong with the simulation. Okay, so when you have done that, you click on setup SWAT run. This will save this information in a file that is called file.cio. I can show you this file. So let me show you. It's in the txt out folder. So the default here stands for the default scenario. You could have different scenarios, and it will, maybe you have simulation 1, simulation 2, and so on. So file.cio, I will just type F, and then here is the file. So I will open it using Notepad++. Let us see. Okay, so the number of years that it's going to simulate is 24 from 1990, and beginning day is 1, of course, and it also shows what is being simulated and what is being read from the from weather files. So if it is 1, then it's measured, 2 is simulated. In this case, remember, solar radiation was simulated, that's why you have a 2 here. And it also shows the weather files, in this case precipitation file, temperature file, relative humidity, wind. And notice there's no solar radiation file here because it's simulating it. And also of interest is the number of years to skip without printing an output. Also here it shows the print code, print code, which is monthly. 0 stands for monthly, 1 for day, and 2 for year. So this is the file CIO to which it saves the information after you click on setup your SWAT run. So click OK, and then this button becomes activated. You can now click Run SWAT, and now it starts the simulation. SWAT run successful. Now we are ready to see the results. The results in SWAT are a bit difficult to extract because sometimes they are not printed in a continuous time series for an element. The only file that you will find easy to extract is the WAT out file. So this prints at daily out step, daily time step, WAT out. Okay. So this will print at the daily time step, and also it doesn't start printing exactly after the warm-up period. It prints for the whole period. And remember, we set it to print at monthly time step. Our results, this will always show in daily time step. So if you open that, okay, a similar file was already opened, so I just reloaded that. So if you look at this column, it's the flow. At the beginning it's all zeros. As I already explained, you will need some warm-up period to get sensible results. So after some time, then you get some values in there, very small flows, and then it normalizes. Okay, so you can import this into Excel and plot it to see how it looks. The other important files, for instance, for subbasins, you're looking for .sub. So output.sub, you will find the results per subbasin. So the way this is structured is that you have the subbasin name here. This shows the subbasin. So subbasin 1, subbasin 2, up to the total number of subbasins, and it repeats for each time step. So this is the time step, and then this is also the time step. Remember, we had 11 and we merged some, that's why we have 9 here. So it will repeat this when it comes to month, the 12th month. It will give an annual summary for each subbasin. Then it starts for the next year, month 1, month 2. As you can see, it's quite difficult to extract a time series for a specific subbasin. If you can script a simple Python script, you should be able to get this easily. But also, if you want to extract this easily, you can still use the QSWAT interface. This also helps you visualize other variables like evapotranspiration, precipitation, and potential evapotranspiration, and all other variables. So let's see how we can visualize the results in QSWAT interface. Okay, so I'm going to minimize all this and close this. And before you already go to visualize, you will need to import your results into the database. And to do this, you come to SWAT simulation, and then you say read SWAT output. So when you click that, you can check the tables that you want to import. For instance, I want to import these, and click on import files to database, and then it shows that it's importing here, and it says done writing files to database. After doing this, then you can visualize your results. So let's close this and click on visualize. So here you select the scenario that you want to visualize. Remember, you have different scenarios for your texting out folder, and you select the kind of data that you're looking for HRU, subbasin, or a reach. First of all, we're going to look at the reach, because this is going to be a time series at the outlet here, and we want to compare this to our observations. So this is rich in subbasin 8, and we want flow out, and we want monthly averages or monthly means. So we add and we select it. So start date and finish date. This is starting date starting in 1992, because from 1990 we had the warm-up period, and the records are only available from 1992. So after you select it here, you click on create. Okay, so I already had such a similar shapefile. Now you can come to plot. I want to plot, and you select the subbasin. I want for subbasin 8, and the variable should be outflow. So I say add to plot, and when I select this and click on plot, it's going to allow me to save this to a comma separated file, and then I will save this to a file. So I name this to flow out 2. I chose the place to save it, and now I have a plot. But also, if I open the project directory, I will find it where I saved it, a time series. Which I can compare to the observations. So here it is. I will open it, and also at the same time I'm going to get back there in the data and go to observed and open the observations. So side by side, well, I could just get from 1993 and put it in here. So I have simulated and observed, and I can plot these. You can check the shortcuts as well, how I have selected all this. So I can plot these in a chart to have them compared side by side. So you can see it captures the seasonality of the flows quite well. And if the blue one is the simulated, and then the orange one is the observation. So the first well, in 1993 the simulated was way higher than the observed, and then they exchanged in the second year, and you can see from this how you're going to modify the parameters to make sure that your simulated and your observed closely match. But that's a story for another part. So for this part we can stop here. I'm just going to show you before I stop this how you can visualize some other variables. You can also add more plots to this. I'm going to go back to this. You can see how it changes in time. So variable, flow out, and when you play, it will show you for each month how much flow you were having in the streams. So I'm just going to move this. So this is how the magnitude of each color. You could do the same with potential evapotranspiration. So I will pause this and then go to static data, and I'm going to add for subbasin, and this is going to be evapotranspiration and monthly means, of course. Add, and then I select that and say create. So I will create it, and then I can move to animation and select that variable evapotranspiration. So now you can see these colors representing the colors you see in this. So this is how the evapotranspiration changes over time in the subcatchment. This is just to give you an idea how the different variables are evolving over time in the subbasin, so that you understand how to approach the calibration for this watershed. So for this part, I'm going to stop here, and then next will be to calibrate and modify our model. Sometimes during calibration you might also need to consider other things like irrigation, and you can implement automatic irrigation if you have some agricultural land where there are irrigated crops. You could also consider including some reservoirs if the representation requires you to have these reservoirs in your catchment, but in this case we don't have those, so this is okay. All right, that's it for now.